Alright, response again to Hythloday. This on more on magnetism and the idea of what a theory is required to provide in terms of depth of explanation. My first argument would be is there's very little depth in terms of explanation of space-time. No way to even imagine it in 3 dimensions as stated, no explanation of the energy, where it comes from. I mean, everywhere else we have to account for energy, yet when the Earth crashes into the sun, we don't have to account for the force that compelled the Earth to do that. It comes from the magic dimension. Not an explanation at all. Clearly there's no explanation of magnetism at all. So I provide you a glimmer of an explanation using this word polarization, this idea of an exchange. You're twice as sensitive to one thing and 0 sensitive to another thing in exactly the same proportion. And that exact proportionality makes it indistinguishable in terms of it won't change your gravitational impact. It won't change any other impact. It'll only change how you impact other magnetic substances. So anyway, he made an argument that you need some clarification. I guess in some point I mentioned briefly, I guess, it's not very important to me anyway, the idea of cutting magnets in half, and that this would be a significant thing in some respect. So, and that they would have to reorganize. Well, I guess I'm saying is, that, yeah, if I implied that, I might have just said that, just as a way of saying, yeah, you cut the magnet in half, it reestablishes as a magnet. But it really doesn't have to, because the magnet is already just a bunch of little magnets inside the magnet. So, if you could just visualize inside this magnet, it would be, this is a bunch of magnets. So there's just, the orange represents the South Pole, and so these are all they're facing, the South Pole is all facing down and the North Pole is all facing up, and this is doing exactly the same thing. The South Poles are all facing down, and so what you end up at the surface is all that matters. So the key to polarization is, so what I'm saying is cutting a magnet any place, it's still the same arrangement. This is all, even though this is behaving differently, it's actually the same thing in a sense. And how to say that more correctly. It's really about the surface. That's all that matters, technically, and the depth of it. So, which are essentially, you could just argue, if something goes in, it's always going to come out whatever the surface identity is. So if something comes in this way, it's going to end up coming out of the green polarization. If it comes in lower, it's going to come out with a tendency to be orange, and certainly going this direction. And so the polarization is always going to be the same. So all you're really doing is reducing the size of the filter. So if I cut the thing that small, it's going to behave exactly the same way. The surfaces will retain the same identity. So it doesn't really have to reorganize. It's just you're changing the density of the filter. So you can just sort of understand, if I have a force coming in this bottom, yeah, it gets polarized orange, and then it gets polarized green. So it comes out green. It can't come out any other way. But what the last thing it goes through will decide its polarization, is I guess the way to say it. So the last thing, it's likely to, when it goes this way, it's likely to exit an orange. When it goes this way, it's likely to exit a green. And that's the way it is. And so he did misdescribe the function of the polarization. So I guess I'll just illustrate that quickly, and to keep things simple here. So what happens is that the universe is randomized in terms of, it's in a lot of colors, but in that color of the random, there's a percentage of green and there's a percentage of orange. And so, but what's happening with magnetism is all some percentage of the ones that aren't green or orange which is the most of them, the 98%, let's say, are changed to green or orange. And so the green is affected by green, which means green absorbs green. So if a green one comes in, what goes out, okay, is something leaving. Okay, something leaves. So if a green goes in, the opposite direction goes out. So this gains acceleration, it gains velocity when a green hits it. And when one of these other polarizations come in, when they come out green. So they come out the thing is sensitive to. So they polarize the ones they don't react to, the ones they don't absorb, they convert to ones they will absorb. But obviously they can't absorb something they're expelling. So the only thing that can absorb it is something else that's affected by it. And so what happens is these greens will hit another magnet. They'll hit the green section. They're going to absorb that acceleration, and this section will move away. It'll accelerate in that direction. If it goes to the orange section, it goes right through. The greens go right through orange, don't affect it at all. And so now the field will push the orange section. It will accelerate the thing because there's an imbalance in the field. So these are the zeros to orange. Okay, and these are the 2x to green. And the orange is doing exactly the same thing in reverse. It has the 2x orange and the 0 to green. So, but yeah, I just wanted to make that clarification because he sort of reversed it in his argument. The greens produce green polarization, and the orange produces orange polarization, and they polarize what's in the field. That's why magnets are so strong, is they are polarizing normal gravity, and now they're not only magnifying the effect in the sense that the 2x effect is now there's going to be more 2x in the field. That's the implication, more 2x in the field. Yeah, so we'll keep it simple and stupid, right? Yeah. So I don't need that. I think there was nothing else there. Cutting magnets, reorganized. Yeah, so they don't really reorganize. They're just a different size piece of filter now. And like I said, just as I cut this little piece off, obviously these two sides stay exactly the way they were, and these sides will just be what they are, which is going to be exactly the same as this. It's all the same. So it's just about what the exterior is going to be. And so as you cut them, you're just cutting smaller magnets into a smaller clump, but there's no need to reorganize per se. Alright, so I think I've done that sufficiently. Yeah, see the other videos for a deeper explanation of the polarization, but it does provide the explanation for the acceleration of things towards each other and the acceleration of things away from each other, which is an absorption of directional identity. They exchange stuff going the wrong way for stuff going the right way. And I guess that's another, to add to this, momentum kind of argument. Another way of looking at it is this. I think I can make this understood. So if I'm a thing and I have an equal balance of stuff, 5 things going this way and 5 going this way and 5 going that way and 5 going this way, and so I'm balanced. Alright, let's say I lose one going this way. Alright, so now I have an extra one going this way. Well, now I'm going to move into this extra field, and so now I'm going to end up hitting an extra one coming in. So it stays balanced, right? I get rid of one, an extra one will come in. My velocity will make me interact with an extra one. So the pressure will, that unevenness in pressure that I left here, will now come in here. And as that one leaves, okay, I'll have another extra coming in, and then that one leaves, and another extra coming in. So you can just see it as the cycle is initiated by the first move in the chess game, so to speak, and then the rest of the moves just happen in sequence. So you can look at it as just a sequence of, first I dispose of something, and now because of that I am exposed. So I dispose, now I'm exposed to extra, but the extra will just be disposed, and you just continue the cycle. So it's just essentially taking a first impulse, which is the out, and then the equal but opposite reaction is the this, and you just keep the cycle going. You keep rolling through the cycle. You keep disposing, and it keeps giving you more. And if you gain more velocity in terms of having more acceleration, which is you dispose of extra, you get rid of 3 extra instead of 2 extra, then you gain acceleration. You'll be exposed to 3 extra. Now you'll have to dispose of 3 extra, and you'll continue that cycle until it goes to 4 or 5 or 6, and you'll just keep disposing of exactly what you're being exposed to. I think that helps. But anyway, so all movement, all velocities follow this rule that you absorb directional identity. You take on something going the way you're moving, and you get rid of something going some other way, either the wrong way entirely, or you get rid of one of the perpendicular ones. Okay, till next time. And theoretically, whether things we never, we have no realistic. We've never taken anything anywhere close, any piece of solid matter anywhere close to half the speed of light or something. So what happens to an actual atom at that speed? I would argue it can't really get rid of its tangents, and once that starts to happen, the atom disintegrates. So I don't think real matter can go anywhere near half the speed of light. I don't think. Anyway, till next time.